Then suppose we have a problem like this and we are asked to calculate the branch currents that are flowing in this circuit. First thing to do is to choose the direction of currents arbitrarily. Suppose that the current is flowing this way here. This we call it I2, and if the result is negative, it means that the current flows in the other direction. This is the first thing to do, and we deduce the voltage drops in every resistor. Voltage drop, remember that voltage drop here, the current flows from the highest potential, the highest potential is here, to the lowest. This is VR1. VR2 will draw it this way in black, so that this is clockwise, this black is clockwise as well, and here is anti-clockwise, so I'll use the red one, VR2, and this one, the current flows this way, is anti-clockwise as well, VR1. So now, how to write the voltage? We have two meshes. In this mesh, so we choose a direction for writing the equations. If you are in clockwise direction, we write plus. So it means if we enter a minus and we get out of plus, it's plus V1, it's black. We can write plus VR2 minus those that are anti-clockwise, because we enter a plus and we come out from minus VR1 small letter minus VR1 and minus VR2 is equal to 0. This is the first mesh. Second mesh, which is here, same thing, in black, in anti-clockwise in red, VR3, this is the highest potential, VR3, the highest potential, VR4, and VR2 in black, no, in red, in this direction, because this is the highest potential, because current flowing this way. Okay, we can say that V2 plus V3, V2 plus V3 minus VR2 minus VR3 minus VR small letter VR3 minus VR4 is equal to 0. This is the two equation, and in this node the algebraic sum of the current should be 0. It means the currents that entering should be equal to the currents coming out. So it means I1 plus I2 is equal to I3. Now let's take the first equations. We'll try to have we forgotten something. Here we have forgotten, I think, we have forgotten V2, source current. We have to is in red normally, anti-clockwise, so minus V2 is equal to 0. Okay, here we haven't forgotten anything. Okay, let's write first equation. v1 minus v2 is equal to vr1 plus vr1 plus vr2 minus vr2. It means v1 minus v2 is equal to r1 times i1 plus r1 times i1 plus r2 times i1 minus r2 times i2. It means that v1 minus v2 4 is equal to r1 is 4, capital R1 is 6, and 2, it means 12 I1 minus R2 8 I2. So we write here the first equation. 4 is equal to 12 I1 minus 8 I2. This is the first equation. Second equation. Is v2 plus v3 is equal vr2 plus vr3 plus vr3 small letter minus plus vr4. So it means v2 plus v3 is equal to r2 i2 plus R3 I3 plus R3 I3 plus R4 I3. So it means V2 plus V3, V2 plus V3, this is 22, is equal to R2. R2 is 8 I2 plus the sum of the three resistances here, R3 12 plus 6 plus 10 I3. So it means 22 is equal to 8 I2 plus 28 I3. We change I3 to this expression, I1 plus I2. The result is 22 is equal to 28 plus 8, 28 I1, and 28 plus 8 is 36 I2. So we write down here 22 is equal to 28 I1 plus 36 I2. If you multiply this equation by 4 times 5, 4.5, it means 8 over 36 divided by 8. So we'll have 4.5 times 4. 4.5 times 4 is 18, first equation, plus 12 times 4.5, 54, 54 I1 minus 36 I2. Here, second one, we'll write it down here, plus 36 I2. So if we sum the two, here we have 40 is equal to 54 plus 28, 82 I1. So it means that I1 is equal to 40 over 82 is equal to times 40 is 0 0.488 amps. From here we can calculate I2, taking one of the equations. 4 is equal first equation. Let's take the first equation, times 0.488 minus 8I2. 4 minus 12 times 0.488, or it equals to minus 8I2. We can write like this now. 12 times 0 times 12 is equal to 5.8 minus 4. This is 1.853 is equal to 8.88 I2. I2 is equal to divided by 8. It's 0.232 amps. And from here we calculate I3 is equal to I1 plus I2 is equal to 0.488 plus 0.232, and I3 is equal to 0.72 amps. So it means the currents are positive. It means that the choice of the direction is good, and that's it. And thank you very much.